The next speaker is Patrick Erickson from ONeill and Company. He actually worked for the capital management division of the company, and he's a long-term colleague, so I'm sure he would talk a lot about the history about the company, but that's not the reason he's here. He's going to be talking about what he has done for the company in the last 2 years.
Right. All right, can you hear me? Am I on? No. My name is Patrick, Director of Data Science at ONeill Capital Management. We are an affiliate of William O'Neill and Company. And I'm here to talk to you about how we've been applying machine learning in the stock market. Coincidentally, I'm a graduate of UCLA, psychology. You may wonder how that's related, but I hope to make the case that it is, that it's relevant. A little bit about us. We are a private money management firm. In the terms of the industry, we're a family office. And if you're not familiar with the term, it basically means we're a hedge fund, but for just one group of companies here. So we don't take outside money. And we have a long history of discretionary management in the traditional sense, where people pick stocks and try and make a profit. And recently, in the last few years, we built a quantitative division. And that's what I want to talk to you about today. So the main thing I want to start with is that being quantitative isn't a new thing. It's not like it got invented in the last few years. And it's not new for us either. Bill O'Neill started investing in 1958. That's 60 years ago. And one of the first things he did when he started is he wanted to know what works in the stock market. And he didn't care about what anybody had told him. He didn't care about his opinion. He wanted to conduct an empirical study of what really works. So he found the best performing stocks of the last 50 years prior to that. He dug out as much information as he could about each one. Now, this is 1958, so he couldn't go search on the internet. He didn't have any XBRL feed or anything like that. And he very, very painstakingly studied this data. And the way he did it was he got a piece of graph paper, and he wrote the ticker symbols down one side, and he picked the data items he wanted to study. He wrote those columns along, and he filled everything out in the middle. And then he got different color highlighters, and he highlighted things that were either good or bad, and he looked for the pattern. So what did he do? He manually built an Excel spreadsheet with conditional formatting. This was pretty brutal. This was painstaking, but he believed in it. That's why he did it. And he learned two things from this exercise, two main things. One is he learned what worked in the stock market. And I'm not saying that lightly. Shortly thereafter, there was a 26-month span where he grew his personal account by 20 times. So just imagine if 2 years from now you had 20 times as much money as you have today. So he did extract empirical information from that. But the other thing he learned was it's a real pain. It's a real pain, and technology can help. So he made massive investments, particularly for that time, in technology and in data. He founded William O'Neill and Company in 1963 with the fortune that he had amassed. He built a database, the first of its kind in the United States, of the equity markets. And since then, built it out even further. We now have a database of all US equities traded on the major exchanges, daily prices and volume from 1880 to the present. 1880 to the present. And we have since added other countries, so we have global information now too. And for William O'Neill and Company employees like myself, this is where we learned about the greatest winning stocks of all time. So that includes some familiar names like Amgen in 1990, Home Depot in 1982, and some less familiar names. One would be Monogram Industries, maybe is my favorite. What did they do? They sold airline toilets. Airline toilets. Now, this was a big deal in 1966. It actually empowered an entire industry of tourism and had follow-on effects in hotel industries. These things just weren't big industries before you could have transcontinental flights. And they, in 1966, went on to, their stock went up over 8 times. So that's pretty exciting. But for most of our history, people have made the investing decisions. So we've had this very quantitative background, and we've kind of done things in 2 prongs. One is we've done historical quantitative research, and that was my job. So I ran the R&D department. We did historical quantitative research. And we then took the insights from that research and put it into our products. Here's an example here. This is our latest generation. This is Panerai. We sell these products mostly to institutional money managers. And you probably can't extract a whole lot from this chart, but people who have been using this chart will see some things that are very useful in here. For example, we have an application that identifies certain patterns in a chart in the prices that we've found are indicative of future price moves. So that's a classic double bottom there. Before this, we did printed products, right? So before the internet was a thing, we had printed products. I was very encouraged this morning actually to meet two people here who used to buy our printed products. So thank you very much. You made me really happy this morning. I feel like I'm among friends. It's great. So we would do quantitative research. We would put it in our products to sell to portfolio managers who make decisions with that quantitative data. And this strategy has been great for us for decades, right? 60 years. But what's the theme of today? Nothing stays the same, right? Nothing stays the same. And what we noticed in our industry, we noticed a couple things. One is that discretionary managers are having a harder and harder time beating their benchmarks, okay? 86% of discretionary managers last year failed to beat the S&P 500. That's not good. That's really not good because you can buy the S&P 500 in an index fund for almost for free. You pay your discretionary manager, so that's bad for their business. But there are some managers who are making money hand over fist. And these are firms that are working in a fully quantitative way. So there are many examples to choose from, but the best, the cream of the crop would be Renaissance Technologies, who went, I don't know how many years without even having a losing month. They just never lost money. They're very secretive and they won't say what they're doing, but what you can ascertain is they are using quantitative methods to invest. They are not doing it the old way with somebody making a decision about this stock or that stock. So several years ago we said, we better get to moving or we might not be here in another 60 years. So we want to build a fully algorithmic practice. Cue the gratuitous matrix reference, okay? There are a lot of things that a quantitative method can do that a person can't. There are certain opportunities that a person just cannot capitalize on. For example, if you have a strategy that makes money by trading 10,000 times a second, no person can do that. If you have a strategy that relies on balancing risk across thousands of assets, no person can do that. If you have a strategy that detects very abstract and esoteric patterns that are just difficult for a person to see in the data, you need an algorithm to do that, okay? And it requires a different set of skills than traditional portfolio management. So traditional portfolio managers, what do? They go out, they talk to management, they know financial research, so they know all about discounted cash flow models and things like that. Well, you have a different set of skills here, okay, that you need to use. And the lucky thing for us is we had been doing quantitative research for quite some time. So we didn't start from nothing. We started with something, although we had quite a bit to learn. Most importantly, what it requires is a new mindset. So if you're building an algorithm is going to trade for you, and you are not going to make the decisions anymore. You are not making investing decisions directly anymore. If you were to compare this to sports, we're going to talk sports later. I'm really excited about that. If you're going to compare this to sports, you're not the player anymore. You're not a player. You're a coach. You're a coach. It's kind of like maybe for a lot of you here, you started your career as an individual contributor, and at some point you became a manager. And your job wasn't to do work anymore. Your job is to help other people do work, right? It's the same thing here, except who are you coaching? It's not a human being. It's a computer. And a computer has different needs than a human being. So, if you feed a piece of quantitative data to a human being, they, especially if they're experienced in the field, they automatically contextualize it. They know what's a normal number, they know what's abnormal, and if you give them a crazy number, they just kind of automatically discount it. It's no big deal. They do it so effortlessly, you don't even notice that they're doing it. But if you give it to a computer, you better have specified a method for accomplishing that goal. Or likewise, if context is necessary to evaluate some piece of data, a person will do it without even thinking twice, but you need to give your algorithm the context to make that assessment. Okay, so we need a completely new mindset to do this. So what's in an algorithm? If you want to, anybody here can do this, by the way. You can go download Python, you can go get some free data from the stock market, you can build an algorithm, and you can interface with the API for a broker and start placing trades. To oversimplify it a bit, there are really only 4 steps. Get data, clean, normalize, abstract, learn to make some useful predictions about what stocks will be better than others, and then build a decision framework for what to do in that case. Now, can you do this without machine learning? Yeah, absolutely. Absolutely. And that's how most people do it. Most people, they get the data, they look at the data, they comb through it, they have an idea, they test it, they try different things, and they build an algorithm. And in fact, we have a number of algorithms that work this way, and honestly, they do just fine. They do just fine. Okay, so why am I talking about machine learning today? Kind of makes my presentation a little pointless, right? All right, let's talk about why. It comes down to speed and scale and scope in the end. There are patterns in the data that no human being can uncover. One of our algorithms, it was trained on 4 billion data points. No person can pull that apart. And that's not even a lot. I'm almost embarrassed to tell you how few data points that is. It's amazing how quickly you get to 4 billion. With machine learning, you can make disciplined predictions, real valued disciplined predictions that account for the level of uncertainty in what you found. Okay, so you can use the predictions that come out of it in a confident way. You know what you're working with. Your improvements are repeatable, right? So you find a better way to do something. Say you have the job, your boss says to you, why don't you make a strategy for the small cap growth market? And you spend a year hacking through it the old way, and you get something that works, and you feel real good about it. Your boss says, okay, good. Now do small cap value. Are you going to spend another year? I hope not. I hope not. If you have a system, you can go faster, right? And in the end, it's all about building and adapting faster. You know, in the stock market, there's a theory that the markets are efficient, that you really can't get ahead in the stock market. You can't get an advantage. And the reason some people think that is that when you find an opportunity and you pursue that opportunity, well, you're not doing that in a vacuum. You actually change the opportunity through your actions. You're putting dollars into that opportunity, which changes the price of the assets you're pursuing. The opportunity gets smaller. And as more people learn about this opportunity, say you're not first, or say you were first, but they catch up, the opportunity gets smaller and smaller and smaller. The only way to find an opportunity is to find a mistake that somebody else is making, a behavioral bias that is persistent. And the best biases come from the people who are chasing yesterday's opportunity. Okay, so you might think you're this fish right here, and you feel pretty good about yourself, right up until the moment you get chomped. So you have to go fast. Speed and scale, they really, really matter. Okay, so how would we do this in a machine learning style? We got our same 4 steps. Let's talk about some examples of what you would do. I'll share some examples of what we're doing and also just generally in the industry what people are doing. The first thing is to acquire data. There's some really interesting work being done. A lot of people are using natural language processing. They either get an economic release and they want to find out if consumer confidence is up or down, and they want to find that out faster than anybody else because they know that will move the market, and so they need to be able to act quickly. Well, you can have an analyst read the release in super speed and then run to the portfolio manager and tell him, okay, it's a buy, buy, buy. And then he goes enter, and that might take a few minutes, right? Well, you don't have a few minutes. You have milliseconds at times because there is somebody who is reading this release using natural language processing and extracting the key information from it. Similarly, people are doing this on Twitter. So they take the whole fire hose from Twitter, they take all the data, and they're capturing things like sentiment about certain tickers, and that actually has shown to be somewhat effective of a way to predict short-term movements. Although it's not perfect, can anybody think of what messes up Twitter algorithms, Twitter scouring algorithms the most? Curse words, almost. It does have to do with teenagers. Sarcasm. Sarcasm. Yeah. So there's just not enough information to know that somebody's not speaking literally, that they're actually saying the opposite of what they mean. So sometimes there are problems. And then, sometimes people use a term that just happens to be a ticker symbol, but they're just using it in some other, it catches on in some other way, it becomes a trending tag. And so you will actually see stocks move really violently, and you're going, what's going on, what's happening? And then you find some unrelated Twitter tag trending that just happens to have the same letters as the ticker symbol. So there's some funny stuff going on there. There's a company doing really great work on company financial statements. So they parse the financial statement, and what they're looking for are sort of language that is ambiguous or sentences that are overly complicated, sort of indications that a company may be trying to obfuscate the truth. So they just kind of measure this value over time, and they see when a company starts using longer sentences, basically, and more complicated words, it's usually not a good thing. It's just like a person who speaks to you in a way that's like sort of just too complicated. You know they're up to something. That really happens with companies too. Another way of acquiring data in a different domain is satellite imagery. So we were talking about this a little bit earlier. We have a geography major here from UCLA who does a lot of work with satellite imagery, looking at these images, and a lot of investment banks are doing the same thing. So what they do is they get satellite imagery of parking lots and shopping centers, and they know where this shopping center is because they have the GPS coordinates, right? They know what stores are there because they have the addresses of the stores from public databases, and they apply a visual recognition system to count cars. They count cars. And they use that to make a prediction for the economy as a whole, and they use it to make a prediction for whether that company will beat earnings or not. So it's pretty cool. It's pretty cool. I imagine, there are probably some weird things that fool that too, like when you do the e-waste recycling at the Home Depot, you get a bunch of cars. They're not necessarily there to buy anything, right? Okay, so that's acquiring data. The step that most people give not enough attention to is cleaning, normalizing, and abstracting your data. This is one of those things, whenever I talk to the guys at work and we're talking about being a data scientist, the reality that I always share is that being a data scientist is mostly being a data janitor, okay? It's mostly just cleaning things up. And actually, in some ways, this is good news. So if you're in a company that is light on data science, okay? You have a big IT group and you're light on data science, and you want to beef up your data science, that's a good thing. You already have a lot of talent in your firm that can help with this step. Your business systems analysts do this all the time. And it's critically important to what happens. So it doesn't get the respect it deserves probably, but it's absolutely critical to what you do. So you can do this without machine learning, of course, but there are some things you can do that really help. For example, in the stock market, unfortunately, everything is an outlier. There is no normal data in the stock market. Everything you look at is just kind of crazy. You pick a financial ratio that should be meaningful, and yeah, maybe 70% of the time it gives a rational number, and the other 30% you just get zany numbers. So you need to have a way of detecting these outliers and mitigating them so they don't mess up everything you're doing. Well, machine learning is good. You could use like a Gaussian mixture model in this case. And what you would do with this is essentially you respect the fact that there are different kinds of companies. You expect something different from a high-growth tech company than you do from a utility company, like we were talking about earlier. And so once you identify these types of companies, you can identify what's unusual for these types of companies. Or more importantly, you can identify data points that don't seem to belong to any of these types of companies. Those are likely outliers. But you can do some other things too, and this is where machine learning really shines, is in abstraction. So having a lot of data is good. Having a lot of data is a big problem. It's a big problem. You have to store it, you have to process it, and when you want to use it later to make predictions, the more data points you include in a prediction, the more likely you are to fool yourself, basically. So you benefit a lot from taking data and boiling it down to the essential bits, just the essential points. So here's an example of one thing that we do. Mutual funds manage a lot of money. They don't manage all the money in the stock market, but they manage a very huge proportion. And they're required by law to file their holdings with the SEC. And those filings are available publicly. So any of us here, any of us in this room could go to the SEC website, and we could see what some of the biggest fund managers in the world, what stocks they own, at least as of their last filing date. Now this is interesting. If you have this record historically, okay, you might have 5, 6, 10, 20 years for some fund managers, and you know the qualities of those stocks historically, you can build a profile for each of these managers. you can see just from what they've done, forget about what they say, they'll tell you, they all kind of say the same thing in the end. You know, we look for well-run companies, growing steadily at a reasonable valuation. Okay, fine. What do they really do? You can see it. You can see it. And then when you step forward to today, you ask a simple question. What stocks out there look right for this fund manager today? What are the ones they would like? And are there any of those that they don't already own? Are there any of those they don't already own? Now, maybe there's a reason why they don't own those stocks. Maybe they met the CEO and they think he's a crook. Okay, it's possible. But things slip past portfolio managers all the time. And it's really interesting to know because what's a portfolio manager, what do they hate the most? If one of those stocks that they should own but don't starts to run, starts to go up and up and up, and then they go to a cocktail party with their friends, and one of their friends who is not a portfolio manager says, hey, Jim, did you know, you see that stock? You must own that one, right? I do not own it, right? They're desperate to rectify this situation. So you could get this event in the stock, for whatever reason the price is going up, and they're going to feel that pressure. They have to dive in. Similarly, when you think on the other side of things, think about the stocks that they own, maybe they own a lot of. It's not their typical kind of stock. How did this happen? How do they have a large position in a stock that's really atypical for them? Well, usually what happened is they bought it when it was different. The stock was different, and they bought it, and time goes by, and things change. Maybe growth slowed down. Maybe the valuation is not so good anymore. It could be whatever it is. It's no longer the kind of thing that they really like. But they're still holding it because they're averse to acting, right? These are nervous holdings. These are not strong hands, right? This is a portfolio manager. When something goes wrong with this stock, they're gone. They're going to dump it. Okay, this is very interesting. And when we first built this profiling system, we actually used it for William ONeill and Company. And we used it almost like a matchmaking service, okay? So if you don't know, William ONeill and Company is an investment advisor. We recommend stocks to customers. And we want to talk to them about the stocks that we like. We're trying to help them make more money by pointing out great stocks. But we don't want to talk just about any stock to any person, right? So we want to talk about one that we like and they like. So it's a dating service in a way, right? So we try to make an automated matching service for these things. And we queue up for our sales team. Here's the stock you should talk to this person about. And not only that, here are the things that this person is looking for in a stock. So these are the qualities you want to focus on. There might be some other things that we care about that they don't care about, but where we have overlap, that's what we want to focus on. So we can speak their language, essentially. So that's how we started. But now let's take a little bit bigger view. We have all these individual models, right, for individual funds. And we know for each fund which holdings they may be feeling a little nervous about and which non-holdings they maybe are feeling like they ought to be in. You can aggregate that up over the entire universe. All right? You can take a dollar-weighted average, really a dollar and confidence-weighted average up over the entire universe. And for every security, you can say, what percentage of this company's total market cap is held by people who are nervous versus what percentage of this company's total market cap could be bought by people who really ought to own this stock by all historical precedent. And so just imagine how many data points are involved in this. Every fund manager throughout history, all of their holdings, all of the stocks, all of their qualities, boils down to one number. It's just plus or minus. This stock is likely to have hidden demand or this stock has hidden supply. That's it. Okay, so that's what I mean when I say abstracting. Okay, and that sort of thing is really great for our models because when we go to predict, we have many, many fewer features that we need to use. Okay. So far, so good? Okay. Making predictions. This is the meat of what we do, really. If you want to invest in the stock market, you need to be able to make some kind of useful prediction about which stocks are most likely to go up and which stocks are most likely to go down. If you can't do that, just buy an index fund. That's not so bad, right? We're trying to do a little bit better than that. So that's why we want to make predictions. And when you hear somebody like me talk about making predictions for the stock market, I hope it will make you chuckle just a little bit, okay? Because it's an absurd idea. The stock market is a very chaotic and dynamic place. You never make great predictions. So you have to work really, really hard to do anything useful here. And that's why most of our effort is here. You see there's some methods here. We talked about some of them today. There are neural nets, in particular the new flavors of neural net, whether it's a convolutional neural net or recurrent neural net, all these cool things, deep learning, they're really awesome. And they have their use. But one thing we found is you don't always need to use the fanciest method, okay? It's not necessary. There are some tasks where you have, first off, lots of data to work with. If you're going to use one of these new methods, you need a lot of data to work with. And it may be necessitated that you use a new method if the domain is highly nonlinear. So if you have all these different features and they come together in complex ways, it's not a simple matter of adding this plus this plus this. There's just very nonlinear, then those methods work. But if you have something simpler, you can get away with a simpler method. You can even get away with not really doing machine learning, doing more of like a statistical method, old school statistical predict. Oh no. Don't be afraid. Just me. I'm ready. Okay, so this is great. But the other thing you find, our main concern is predicting what stocks will go up the most and how volatile will they be. But one thing we found as we started this is when we look at the decisions we make managing a portfolio, prediction is everywhere. Everything's a prediction. Nothing is certain. Here's a simple one. Say I expect one stock to go up 5.5% over the next month. Okay, that'd be pretty good, right? And I don't own that stock. I own one stock that I expect will go up 5%. Okay, should I switch? The answer is it depends. If transactions are free, then sure. Then yeah, I should make the switch. But there is a cost to every transaction, and the cost is not obvious. The cost includes the money I pay to my broker, which is pretty small actually. It includes the spread of the stocks. There's a difference between the bid and the ask. And if I want to buy, I have to pay the higher price. If I want to sell, I have to pay the lower price. So I'm going to pay that spread. And it includes the fact that if I want to make a big trade, say I'm moving a lot of money, there might not be enough sellers at this level. I might have to find more sellers higher up. So in the end, I need to know stock A, which I own, I expect 5%. Stock B, which I don't own, I expect 5.5%. I need to know how much it's going to cost me or predict how much it's going to cost me to make that transaction. And it ends up being really important. So we have a predictive model for return. We have a predictive model for transaction cost as well. Here's another one. This one is even more kind of surprising that it matters, but it really does. I go to buy a stock today. So there's news about some stock. They just had a good trial for their developmental drug, and everybody's excited, and stock's trading like mad, it's going up, and I want to buy right now. Okay, great. Maybe I can afford to do that. And someday, I will need to sell. I will need to sell someday. And I need to know, I have a certain amount of money that I'm investing. And knowing that every time I buy or sell, I move the stock, and that if a stock has more liquid, more people are trading the stock, I'll move it less. If a stock has fewer people trading the stock, I'll move it more. I really don't want to move the stock a lot. So I may be able to buy it today, but I need to know a week from now, a month from now, a quarter from now, when I sell, will this still be a liquid stock? See, it's liquid today just because there's news. But this may be a stock that it's just a little biotech company, and most of the time it does nothing. So a month from now, when I go to get out, I realize I'm stuck. I'm stuck. That's bad. That's bad. So even though I see an opportunity, what looks initially like an opportunity, it may not be an opportunity. Okay, so prediction is kind of, it's everywhere, really. It's everywhere. And if you look at your business, you'll see the same. Every decision that you make has some uncertainty. And some of the predictions and the models, the mental models that your staff may use to make those decisions, they're kind of unspoken. They're such a part of the fabric that you don't even think of them. But when you really get down to it, you'll see that it's there. Okay, finally, you need a decision framework, right? You made a prediction, good for you. If this were a Kaggle competition online, a data science competition, that's all you need to do. You need to take action. You need to take action. So this is where you need to marry your data science, your predictions, with the business rules. Now, in investing, there's a whole collection of tools in quantitative finance that help us do this. Thank goodness. A lot of really smart people have kind of worked it out. But it may or may not be quite as obvious in your industry. And most importantly, these things are not really separate. The way you make decisions and the way you make predictions, they have to align, right? The information you need to make the decision, unfortunately, is almost never very amenable to optimization for prediction. So you have to figure out how to predict something as close as you can to what you need, and then deal with that in your decision-making process as best as you can. Now, there are some cool things here. We're not doing this yet. I can't wait to do it. Reinforcement learning. So in quantitative finance, a lot of it's all worked out. You kind of know what to do once you have the inputs. But there are a lot of fields where it's not entirely clear. You know, there may be some free parameters you need to adjust as you're thinking about. Maybe if you're building a dating site, you know, you need to decide how strong does the match need to be before you suggest that two people talk to each other, for example. You don't know the answer to that question, right? You don't know the answer to that question, and it's not really clear. Well, reinforcement learning is one way to solve that. So what you do is you essentially set up a flexible policy for decision making, and you build an engine that makes decisions partly at random. And it tracks the outcome of those decisions. So it gets some reward. In the stock market, it would be, hey, your portfolio went up. That's a reward. That's good. If it was a dating website, it would be two people, you know, went on a second date, maybe. And over time, it biases its decisions towards the policies that were successful. So that is a way to deal with this optimization problem of these free parameters. And it's actually really important because when you think about the speed you're trying to achieve here, remember, we're not trying to build a great algo, really. We are. But we're trying to build the capacity to build great algos in an almost trivial way. So if you're going to do that, you want to remove as many of your decisions as possible. You don't want to make decisions. You want to set up a framework where decisions get made, optimizations happen, and a strategy is created. That's what this kind of thing is all about. The fewer decisions you can make, the better. Machine learning isn't new. Not new at all. We talk about it like it's an emerging technology, right? So here's some common methods that are popular today. K-means, 1957. Logistic regression, 1958. Neural networks, 1958. 1958 is when Bill started investing. Hidden Markov models, 1959. Support vector machines, 1963. That's when William ONeill and Company was founded. Total coincidence, but it's cool. So these have been around for a long time. So why are we talking about it now? Here's what is new. It works. Many people have put in decades of really hard work to make this stuff practical. That's what's different now. So you don't have to hire the world's preeminent statistical researcher in order to do support vector machines anymore. There's a Python library that just does it, right? They've worked out the things that tend to go wrong and how you can correct for that. It's fast. If your machine is not fast enough, you rent out a server in the cloud and you can have as much power as you like. So the barrier to entry is very low. Anybody here could leave this gathering, go home, go to anaconda.com, download an Anaconda installation of Python, take a couple minutes, and in that installation are all the libraries you need to perform any of the methods I showed you on the prior slide, any of those methods. And even more so, any of those things will take just a few lines of code. It's easy. It's actually easy to do machine learning now. So that's exciting. That's really exciting. That means there's very low barriers to entry and to use these very powerful tools. But machine learning is powerful kind of it's a powerful tool the way a flamethrower is a powerful tool. It will do a lot. It will do a lot for you. It doesn't mean you should use it all the time, and it does mean that you should be careful when you use it, right? There are ways that you can go wrong. If you don't understand what you're doing as you use this, If you just kind of use it blindly, you're going to get results, and you're going to take them at face value, and then you're going to lose all your money. That's how it works in the stock market. Okay? So what it means is, for us as business people, this is not a differentiator. Machine learning is not a differentiator. Machine learning itself is just a tool that everybody has. So how do you differentiate yourself? Okay. Here are some skills that I think are really important. Okay. You need to translate domain knowledge into code. All right, especially if you're an incumbent. If you're a startup and you're just starting from scratch, well, you might not have any domain knowledge, so just go for the technology solution and you're good, okay? But if you're an incumbent, and most of us here belong to incumbent companies that have been around for a long time, your company is around for a reason. It's been around here all this time. At the very least, it hasn't made a disastrous mistake, right? And this is especially true in investing. If you can find somebody who's been investing in the equity markets for 20 or 30 years, you really need to listen to what they're saying, because by definition, they didn't blow up. They're still in the game. You need to encapsulate that knowledge into what you're doing. But what you need is somebody who can translate that into code, and that's not always simple, because the business experts they cannot express it accurately. They cannot express some of these principles accurately or completely. If you ever listen to a portfolio manager talk about their process, it sounds like kind of mystical, and they're talking about patterns on the chart, and you're going, I don't get it, right? I don't know what to do with this. So this is a non-trivial step. But once you've done this is part of your IP, right? The algorithm is actually not the IP. It's the process that creates the algorithm that's the IP. You've got to connect your predictions to a business goal. Duh. We talked about that. It's not as trivial as it seems. In the stock market, you ask somebody what they want. They say, I want a stock that goes up a lot. Okay, that's actually easy to deliver. That's easy to deliver. You may not like the results, because it'll be some teeny little small cap that's like the most volatile thing in the world, and no sane person would ever hold that stock. So you need to spend time thinking about what you really want to deliver to the customer. And in all likelihood, they cannot express that to you completely. They can't express it. Use the right tool for the job. So we talked about the latest, fanciest neural networks. We talked about simple things like good old linear regression. There's a place for all of these things. And what's necessary, and if you're building a data science group, for example, is you need people who know how to select the tool. They need to know the assumptions that underlie that tool. They need to know what can break it, right? How does it break? Because the natural tendency that we all have is just to take the latest and greatest and just apply it to everything and see how it goes, right? But that is not always the best move. Sometimes you should just keep it simple. You need to build for out-of-sample performance, okay? So you're going to build a model, you're going to do some tests, and as you refine, those tests are just going to look better and better and better, right? And then you'll say, yeah, we got the best test ever. And then you release this thing out into the real world, and it doesn't work. Because what happened is you were testing and refining all on the same data. That's the problem. Now, the standard answer that people will give you, oh, when you build a model, you're going to set some data aside to do out-of-sample testing. And that's all fine and dandy, but here's what happens in real life. You set the data aside to do out-of-sample testing. You train your model on this training data over here, right? Then you say, okay, we think we got it. Let's check it on our out-of-sample data. It looks terrible. Okay, let's learn what we can and go back and do it again. Guess what? Your out-of-sample data is now in-sample data. Happens all the time. Happens all the time, and it's unavoidable. It's unavoidable. So you'd better hire data scientists that at least know that that's a problem. Better hire data scientists that at least know what cross-validation is, okay? There's a cross-validation graph over there. Not that complicated, but you'd be surprised how many people skip it. And then you really need to build a pipeline. So the pipeline is how you ingest new data, extract insights, and deploy, and then measure what happens so you can do it again. You have to be able to go quickly. All right. So here's where we are now at ONeill Capital Management. Started a couple years ago. We have 8 algorithms in 3 countries. We're getting better cycle time each iteration. So the first algorithms took, I think, a year and a half. Took a long time. Well, it took a long time to get it all in place, figured out. Then it was a year. Then they started taking 6 months. And we're getting that sort of I don't think it's going to cut in half every time, but it's starting to happen that way. We're able to tailor algorithms now for different mandates and different risk profiles. So if our chief investment officer comes to me and says, I need a small cap value algorithm in India, we can do that. We know how to do that now, okay? And it's not some massive project that we have to figure everything out. We have a pipeline and we can do it. If the chief investment officer comes to me and says, you know, we've got all these high-flying growth algorithms, that's what we like. That's what we like best, but we really think we could sell a more conservative style algorithm. Okay, we can do that. We just turn some knobs, build something else. It doesn't take any particular act of genius or any heroic effort anymore. We just do it. And because we can do these things, we can generate diversified returns. So we're not doing the same thing anymore. We can generate algorithms with specific characteristics, and that allows us to not all lose money at the same time. That's really the key, right? So this ends up being really important for any large-scale operation. So we're feeling good about it. We have a lot more work to do. Ultimately, I'll leave you kind of with what we learned. First is that stock market is a machine designed to frustrate data scientists. It really is. It really is, and just about everybody else too. If you want to know what the right thing to do is in the stock market, it's probably the opposite of whatever feels right to you. It's probably the opposite. And if you think about a way that a problem could become statistically nearly intractable, that's probably how the stock market behaves. So there's a lot going on there. If you are interested in the topic, I recommend reading Nassim Taleb, who has several books out. There's Fooled by Randomness and The Black Swan. He has some very, very insightful things to say. Yes.
Will he buy that or does he invest his way? He has told us up to this point.
Yes.
He believes in making things simple.
Yes.
So if everybody says there is going to be war, he doesn't go to this program. He buys an option.
Yes.
He can lose $300,000, which he can afford. But if everybody is wrong, which they are most of the time,
yeah.
he's going to make millions.
He makes millions, and he has done exactly that. Yes.
Does he use that system?
He does not use this system. He probably would not like my system. Yeah.
You read this book.
Yeah. Yes.
So I think
Yeah.
his way is to do things simple. And
Yes.
I think there's a lot to be said if you found a way to get all this information, but also use some of the news which tells you is going to create a kind of fear, which makes people do things which has nothing to do with data and logic.
That's absolutely right. Yeah, I think you need to keep it as simple as you can, because you will delude yourself by making it too complicated. Fancy is not better. Fancy is not better. And if I take it, Nassim Taleb really likes to use options, which we don't trade right now. But the main thing that I take from his writings is a sense of humility. You know, a sober. It's very sobering that the news that he brings is existentially bad in a way.
An SOB in many other ways.
Yes, yes, absolutely. His Twitter feed is quite entertaining, let's say.
I come
Yeah.
from the same part of the world, I know.
Yes, yes. So, but if you don't have some humility about what you're doing, you're going to embarrass yourself. You're going to embarrass yourself in the end. So, and this kind of gets to this part, and that is, you will never have strong predictions in the stock market. You're never going to know what's going to happen with certainty. You just won't. Anybody that tells you they do is lying to you, or they are a fool. Okay? They're a fool. What you need to know is how bad your prediction is. Hopefully better than chance, but probably not much, okay? As long as you just know realistically how bad it is, you can pace yourself accordingly. You're not going to take massive risks on that information. That's really important, just as important as the prediction itself. Similarly, and I think this is kind of from Taleb too, some errors are more important than others. If you assume something is safe and it turns out to be risky, that is a much worse error than assuming that something is risky that turns out to be safe. It's an asymmetrical risk that you have. And so once you know that, once you see how those errors affect your outcomes, your actual process, you need to go back to all the way to the beginning and build that in from the start. Say, I'm going to build my process to avoid not just error, but I want to avoid the bad errors, the bad ones. And the other thing that we learned is you really do need to look at the output of your model. It's just too easy to take a ton of data, run a machine learning process on it, and then take the output at face value along with some R squared and you think you did really good. When you look at, on a granular level, the actual examples, you come to see all the crazy things that your model is doing, and you understand how maybe way upstream you made a mistake in data normalization, or maybe your samples bias, and you need to go back around and correct that before you go forward. Because it never works the first time. It just never does. Okay, so you have to look at it in detail. And that's it. Any questions? Thoughts? Yes.
And I was wondering, how much do your algorithms take into account things like Musk smoking a joint in front of, like, you know, a webinar or something like that? Is that worked in, like, crazy CEO, or, you know, like, how does that get modeled?
Yeah, currently I don't track Elon Musk other than my own Twitter feed. I find it pretty entertaining. But yeah, there are things like that that you say, wow, this is nuts, right? It almost seems unprecedented in a way. What's interesting is if you go back through history and really study history, you find out that there have been lots of crazy CEOs throughout time. And you might not always know where they are, but the effect that occurs happens on the price. And so sometimes you see what's unfolding in the price anyway. There are times when you can be right about what's going to happen in the world and still wrong about what's going to happen to your stocks. That happens all the time. So sometimes it's not best not to know, but sometimes not knowing what's happening in the world is actually okay as long as you see what the stock is doing. People, you know, there are people that really criticize sometimes that sort of reasoning, which we call technical analysis. But as a psychologist, to get back to your question, what is the stock market? It's just the output of a billion individual investment decisions from millions of people who are afraid or greedy or hopeful or, you know, just living their lives, right? So that kind of psychology, it manifests itself in the behaviors. And really, in the long run, the only way you can make money in the stock market is to find an enduring bias in people's behavior. Some suboptimality in the way people invest. That's how you make your money. And thank goodness that people are not perfect, otherwise I wouldn't have a job, I wouldn't have anything to do. We would have an efficient market, but luckily we don't. Yeah.
But isn't that also the reflection of expectations?
Absolutely. Yeah, and that's where it really gets confusing. We were talking today about, I won't say the name of the stock, but it was a stock that has been making lots of money, and they reported earnings, and they beat expectations, and then the stock was down 20%. You say, what happened here, right? Well, what happened is they beat the formal published expectations, but people have been following them beating the formal public expectations for so long that there's this shadow number that everybody has in their head. They say, oh, no, they're really going to do even better than that. And they didn't meet that hidden number, and now the whole thing blows up. So it's really that expectation and those changes in expectation, and it's not even what people say or what is published, but it's what they're really hoping for or thinking that drives it. It makes it very, very difficult. Yeah.
When I think about other companies that are using algorithms, specifically LinkedIn, more to push content.
Yes.
One of the pitfalls of algorithm-driven like content is that you end up, because I liked or because I commented, I end up with the same thing.
Yeah.
And hey, filet mignon is great, but filet mignon for breakfast, lunch, and dinner every day for the next 16 years is pretty rough. And so where's the technology in terms of kind of determining that, hey, we're humans and every once in a while we like a little bit of variety and something totally unexpected? And
that is a great question. Do that? Yeah, there are companies that are dealing with that challenge. I have the same experience you do on Goodreads. I use Goodreads to rate books I like and get suggestions, and that was really great for maybe 6 months or so, and now I always get the same stuff. I don't get anything new. That's one place where reinforcement learning can be really helpful. I mentioned that reinforcement learning, it acts somewhat randomly. So it's it knows what it thinks you're going to like, and then it has a bunch of things that maybe these are dicey, But it will actually just throw one of those in there now and then, just completely at random. And there's some, I think Spotify will intentionally boost random things now and then to just try and elicit some response from you in a way, maybe discover something that they didn't know. Yeah.
So I have to move on to the next topic. Thank you, Patrick.
Thank you, Terry.
All right.
Oh, pleasure.